Hey there, everybody. Welcome to Common Sense Math, where I help you see, say, hear, listen, think, do, write, and sometimes even taste the math coming to life using the 5+1 senses. Today's problem is about triangles have three sides, three angles. So the problem with triangles is there's so many different types in the way that we classify them. A lot of students and sometimes even teachers, us adults, get confused about the different names of triangles based on the number of sides. No, just on how long the sides are and the measure of the angles. So I'm going to give something away that I was able to find on the internet as part of the prize for watching this video. So be sure to email me at the word writing __ doctor spelled out at yahoo.com. I don't have a math _ doctor email, so I just kind of make sure all of you send your emails to the same place. So triangles have three sides, three angles. So let's take a close look at the document that you're going to get that will help you and your students differentiate some of the differences between the angles that we classify by the number of sides or the types of angles. So here we go. Sides. Whenever 0 sides are congruent in length, they call that a scalene triangle. I want you to notice a triangle can have two names, like my name is William Charles MacDonald. I'm also called Bill. I'm also called Billy. Another name is Dad, Honey, Babe, Sweetheart, depending on who's talking to me. And I'll answer to all of those if the circumstances are correct. And so if the circumstances are correct, some of the triangles that we're going to talk about today have more than one name. Still staying on the blue side, isosceles has two congruent sides. And I don't like that whoever made this didn't put an S there because it needs to be sides. And the way that works is if this side is congruent to that side per se, then the opposite angle of that side will be congruent to the opposite angle of the other side whenever there's isosceles. So keep that in mind, and it's in my mathematics chart that I'll show you in a moment. When you have an equilateral triangle, they fixed sides there, three congruent sides in terms of length, and they will all be, because the angles will be the same, since a triangle is half of a square and the degrees of a square or a rectangle add up to 360 degrees, then half of any rectangle or square would be 180. And so if we know that an equilateral triangle has three congruent sides in terms of lengths, then the opposite angle will also be congruent. So 60 plus 60 plus 60 equals 180 degrees, or 60 times 3. So an equilateral triangle is going to be equal to 60 degrees. On the other side, Let's talk about angles. If they ask you for a right angle, the only way to get the right angle is to have exactly one that equals 90 degrees. 90 degrees. Huh. Right angle. Huh. Perpendicular lines are needed to form that right angle. Obtuse, when you open it up a little bit bigger. So that T that you see there, that capital T is an actual formation of two right angles that are just upside down. So whenever you open up one of those angles becomes obtuse and one becomes acute. If you flip it the other way from that capital T, one of them becomes obtuse and one of them becomes acute. Depends on how you move them. So you might circle that capital T in obtuse and remember that one of them will be wider open than 90 degrees. Another angle that we're going to talk about is an acute angle. Acute angle, an acute triangle, I'm sorry, has three acute angles. In other words, they all have to be less than 90 degrees each. Now, for those of you who have the mathematics chart, in the addition section of the keywords chart, there's your angles there. Angles. Acute is less than 90 degrees. Obtuse is greater than 90 degrees. Right equals 90 degrees exactly. The angles form perpendicular lines. The triangles, scalene, no equal sides or angles. Isosceles, which went a little more, it goes into more detail than that picture that I showed you. Two equal sides and two equal angles. And equilateral, three equal sides and three equal angles. So there is the reminder of the different type, but remember that sometimes a triangle can have more than one name. And so what I'm going to do for you today is my number 18 from 4th grade. So if you're working with triangles, you might ask for my free types of sides and angles on triangles. So let's take a look and see why more than half of the students in Texas struggled with triangles. Okay, the question, which type has exactly one 90-degree angle? Well, letter F, isosceles. G, acute. H, right. And J, scalene. Okay, the one that I can for sure eliminate is acute, because I remember that an acute angle, all three angles have to be less than 90 degrees. Okay, the other two I want to eliminate for you is an isosceles triangle, that even though this right here is a right isosceles triangle, one of the angles is equal to 90 degrees, and it could be, and what that would mean that two of the sides have to be exactly the same length. So even though this is not a right isosceles, because the two connecting sides of the right angle usually are the same length, and so it would be one of these other lengths here to form the isosceles, and the angles would be, the opposite angles would be acute. So because that's too vague, just says scalene, it doesn't necessarily mean it's a right triangle. So I'm going to eliminate that one. Scalene, they're all unequal in length. We can have a right triangle like this one that's has all unequal lengths, but because they were specific, one of them has to be 90 degrees. I can't just go based on scalene alone. That's too vague. So let's take a look. Isosceles as a reminder, letter F. Why am I going to eliminate it? An isosceles triangle has two sides that are equal in length, and the two angles that are opposite each other will be equal. Could it be acute? Yes, as long as all three angles are less than 90 degrees. So keep that in mind. There's side A and A of the same length. The opposites are the same angle. And equilateral, remember all three sides, AAA, are the same length, and all three angles are equal. They all have to be 60 degrees. Obtuse, O big, one angle is going to be greater than 90 degrees. So keep in mind that T, and you can flip that T upside down to practice it the other way as well. So when you have the right angle and you open up one of them, the one that you're looking at right now, the left side becomes obtuse and that right side becomes acute. If you flip it the opposite way, the left side becomes acute and the opposite side becomes obtuse. So there you have it. The only one that's specific enough where there's exactly one 90-degree angle, we're going to call it a right triangle, and it will usually have the little square to let you know there's a 90 degree. It forms the corner of a square right there. So there you have it. Feel free to email me for the free document. This one right here that shows the triangle classifications. You'll just have to do like I'm going to do right now. I'm going to do something that you'll probably have to do if you want correct grammar. Let's see if I can make this work so that you can see it. I'm going to try. I got my little light blue, two congruent sides. I remember that the angles that are opposite of the congruent sides also have to be congruent. So just a suggestion for those of you that need it. And apparently we need to practice different types of triangles because it seems like the state tests triangles of different types and forms each and every year. And we just got to get that down in our head so we can memorize if a triangle has more than one name, what are the characteristics that it needs to have in order to have more than one name, such as Bill, Billy, William, Charles, Dad, honey, sweetheart, babe. Thank you guys so much. Please tag your math teacher friends who are working on geometrical two-dimensional shapes. If you have the any of the surgeries for 3rd through 8th grade, you also get the mathematics posters that have actually 2 pages for two-dimensional shapes and 2 pages for three-dimensional shapes. So you can work on those kind of questions with your kiddos. And thanks so much. I appreciate your positive input and feedback. It's so nice. You know, I do this for free. I don't charge anything. It's just to help people who purchase the math surgeries to see one way to actually do it, not on a written directions, but a live recording, well, a recorded live version of me kind of sharing the different difficulty questions and perhaps one way or two ways how to solve them. So make sure you tag your math teacher friends and have a wonderful rest of your day.